Okay, the intermediate algebra final exam review, page 4 and 5. Number 11. If f of x is equal to 2x minus 2, g of x is equal to 4x squared minus 3x minus 2, and h of x equal to 8x squared minus 7, find h of 4. Okay, so we want to find h of 4. So we'll have to use the function h of x. Okay, so h of 4 is equal to, okay, see if we want to find h of 4, we just replace the x's in h of x with a 4. So 8 times 4 squared minus 7. Okay, and then we just simplify the right side of this. Okay, so you should know your order of operations. First you square, so 8 times 16 minus 7. Okay, then we do multiplication, so h of 4 is equal to, so let's see, 8 times 6 is 48, 8 times 1 is 8, plus 4 is 12, and then minus 7, 128 minus 7 is 121, so h of 4 is equal to 121. All right, the next one, number 12, graph the linear equation. Okay, and then we'll use the graphing tool to graph this. So we want to graph y minus 1 is equal to 0. So in order to graph this, we'll want to solve for y. So add 1 to both sides. We get y is equal to 1. This is the equation of a horizontal line. Okay, so you just go where y is equal to 1. You can plot a point. You don't really need the point. Well, the graphing tool, you'll probably need a point, and then it's just a horizontal line. So this is the line. Y is equal to 1. Graph the linear function by finding the x and y intercepts. Then write the equation using function notation. Okay, so if you do not graph using the x and y intercepts, even if you get the correct graph, you will get this problem wrong. Okay, so you need to do what the instructions are telling you to. So to find the x-intercept, that's where the graph is going to cross the x-axis, which means the y value is always going to be 0. So if we want to find the x-intercept, we plug in a 0 for y and we solve for x. So we have x minus 0 is equal to negative 1. X is equal to negative 1. So the x-intercept is negative 1, 0. Okay, we can graph that. Negative 1, 0 is the x-intercept. Now we need the y-intercept. The y-intercept is where the graph crosses the y-axis. So look, you can see the x value is always going to be 0. So we can find the y-intercept by plugging in a 0 for x. 0 minus y is equal to negative 1. Negative y is equal to negative 1, which is y is equal to 1. So the y-intercept is 0, 1. So let's graph that. 0, 1. Now that we have the 2 points on the line, we connect them. And the next step is write the equation in function notation. That's just having it in the f of x is equal to mx plus b form. Remember, f of x is just a replacement of the y. So if we solve this equation for y, then we'll have it in function notation. So we have x minus y is equal to negative 1. So if I add 1 to both sides and I add y to both sides, we'll have x plus 1 is equal to y. And that gives us the y we replace with f of x. So f of x is equal to x plus 1. And you can check too. See, the y-intercept is 0, 1. The slope is 1. So you can go up 1 over 1, or you can go down 1 over 1. See, it matches the line we already have graphed. Okay, number 14. We just want to find the slope of the line that goes through the given points. Okay, so in order to do that, you need to know your slope formula. Slope is y2 minus y1 over x2 minus x1. So now we'll just use the points. So if this is x1, y1, and this is x2, y2, we would have 4 minus 8 over 2 minus negative 1. Okay, and it is easy to accidentally, just put the wrong number in the wrong place even if you know the formula. So it's worth just double checking that you plugged everything in correctly. And just pay special attention when you have a negative as well, that you have a negative is going to make that positive. So we have negative 4 over 3, and that is simplified. So the slope is m equal to negative 4 over 3. Okay, next page. So now this is page 5, starts with number 15. Okay, find the equation of the line through the point 3, 7 and parallel to y is equal to 2x plus 2. Write the equation using function notation. Okay, so for this one, we need to know a couple of things. So for number 15, okay, we need to know that parallel lines have the same slope. Okay, so you need to know that fact because we want to write the equation that's parallel to this line. So what is the slope of this line? Well, mx plus b, m is our slope, so the slope is equal to 2, which means the slope of the line we're trying to find is also equal to 2. So we have a point, 3, 7. We have our slope, and now we can use point slope form to get the equation of this line. Okay, you can use point slope form, you can use the y-intercept form, solve for b, and then rewrite it in function notation. But my preference is to use point slope form, so that's what I'm going to use. So point slope form, y minus y1 is equal to m times x minus x1. And then we'll just plug in. Here's my point. My x1, y1 is 3, 7. My m is equal to 2, so I'll plug in. Y minus 7 is equal to 2 times x minus 3. And we want this in function notation, so we just have to solve for y. So I'll distribute first. Y minus 7 is equal to 2x minus 6. And now we'll add 7. Y is equal to 2x plus 1. And function notation is just replacing y with f of x. So the f of x is equal to 2x plus 1. That's what we'll type in my method. Okay, number 16. Graph the inequality. Use the graphing tool to graph the inequality. Okay, again, however you want to graph is fine. You can use the intercepts, or you can solve for y and then use slope-intercept form. I like to solve for y and use slope-intercept form. So I'm going to have 2x plus y is greater than 3. Okay, I'm going to subtract 2x from both sides and get y is greater than 3 minus 2x. Okay. When graphing the inequality, you have to pay attention to two things. Are we graphing this line with a solid or a dashed line? And then when I graph the line, am I going to shade above or below? So first, when you have the inequality, the strict inequality, greater than or less than, graph with a dotted line. Okay, and then if it's y is greater than, shade above. You could always use a test point as well, but if you have it y greater than, okay, it has to be in this form where the y is to the left, then you know you shade above. Okay, so let's see. So we're going to graph y is equal to 3 minus 2x with a dotted line, and we're going to shade above. So here our slope is negative 2 over 1. Okay, that's the coefficient of x. And then the y-intercept is 0, 3. Okay, so we'll plot the y-intercept, 0, 3. The slope, go down 2, right 1, because it's a negative 2 in the numerator, so down 2, positive 1 in the denominator, right 1. So from our y-intercept down 2, 1, 2, right 1, plot another point. And then we can do our dotted line through our points. And then we are shading above. If you want to check to make sure you shade it correctly, pick a point on either side of the line. Just make sure it's not on the line. I'm going to pick 0, 0 because that's a really easy number, really easy numbers to work with. You may not be able to pick 0, 0 if it falls on the line, but it doesn't, so we can. So this is how you check. So if we're checking the point 0, 0, okay, x is 0, y is 0, we'll plug it in here. 2 times 0 plus 0 is greater than 3. Okay, we'll simplify to see if we have a true statement, okay, because we're not really sure yet. 0 is greater than 3. Is that true? It's not true, which means we shouldn't have shaded the side of the line that that point fell on. And notice it's not shaded. So we shade it, we know we shade it correctly. Okay, number 17, solve the system of equations. Okay, you can use any method you like. You can use substitution, or you can use the elimination method. I'm a fan of the elimination method unless it's an obvious choice to use substitution. But how it's set up, I don't think it's, you know, any easier to use the substitution over the elimination. So I'm going to use the elimination method. Okay, so the elimination method, we need to try and eliminate one of these variables. Okay, so if I multiply the first equation by a negative 3, then I'll have negative 6x and a 6x. So when I add the two equations together, it'll eliminate the x's. So I'm going to multiply the first equation by negative 3. So that'll be negative 6x minus 18y is equal to negative 63. Okay. We don't have to do anything to the second equation, so just recopy that. 6x plus y is equal to 12. And now we add the two equations together. Negative 6x plus 6x cancel out. Negative 18y plus y is a negative 17y. Negative 63 plus 12 is a negative 51. And now, with this equation, negative 17y is equal to negative 51. We can solve for y by dividing both sides by negative 17. So y is equal to, I'm guessing it's 3. So 3 times 7 is 21. Carry the 2. 15 plus 2 is 17. Yeah, so we get y is equal to 3. And now we use this solution. We plug it into either of these two equations to solve for x. Okay, so it doesn't matter. I'll just use the second one. So 6x plus y is equal to 12. And again, we know y is equal to 3. So we have 6x plus 3 is equal to 12. Subtract 3. 6x is equal to 9. Divide by 6, and we have x is equal to 3 over 2 when we simplify 9 over 6. So there is one solution And we write it as an ordered pair, so x and then the y, so it's 3 over 2, comma 3. Very good. Number 18. Okay, we simplify, use positive exponents for any variables. Okay, so you need to know your rules of exponents. So let's simplify this. So let's see, we can simplify the 5 over 15. Okay, so 5 goes into 15 3 times. So the coefficient would be 1/3. Okay, for here, a to the negative 6th and a to the 4th, well, those have those two factors, the one from the numerator and the one from the denominator, have a common base. And since it's division, we can subtract their exponents. Okay, the little trick is you subtract from the one that's larger. So here's my, right now we have a 1 in the numerator. I'm not going to put that yet, but here's the 3. Okay, since 4 is greater than negative 6, I'm going to subtract negative 6 from 4. So we have a to the 4th minus negative 6. Okay, and then we have b to the 7th over b to the negative 5th. Again, the rule is we have same base and a quotient, so we can subtract the exponents. Since 7 is greater than negative 5, I'm going to subtract negative 5 from 7. So it'll be up here, b to the 7 minus negative 5. Okay, and then we just clean this up, so it's b to the 12th over 3 a to the 10th, and that's all. So b to the 12th over 3 a to the 10th. And again, you could have used your different rules. You could have first gotten rid of the negative exponents using the negative exponent rule, and then you could have used the multiplication rule. As long as you're using your rules correctly, okay, your work may look a little different than mine, but the answer, the final answer, should be the same. Okay, and that is b to the 12th over 3 a to the 10th. Okay, let's do number 19. Simplify. So we have x squared times the quantity x squared bc raised to the negative 5th. Okay, so using our order of operations, we would do the exponent part first. So we have to work on this circled part first. Okay, so we're not doing anything with this factor x squared, so just recopy that. And now the power rule is we multiply exponents to every factor inside the parenthesis. So we will have x to the negative 10th, b to the negative 5, and c to the negative 5. Okay, we want to use positive exponents only. So we have to, right now if you're looking at this, we have negative exponents, so we know we have to do more. But we have a common base here, x squared times x to the negative 10, so we can combine those two by adding their exponents. Okay, so 2 plus negative 10 would be negative 8, so x to the negative 8, b to the negative 5, and c to the negative 5. Now using the negative exponent rule, any factor that has a negative exponent in the numerator, you can move to the denominator and it gets rid of the negative exponent and makes it positive. All right, so 1 over x to the 8th, b to the 5th, c to the 5th. And that's all we can do. So this simplifies to 1 over x to the 8th, b to the 5th, c to the 5th. All right, and that concludes page 4 and 5.